Okay, hi, and welcome to my stream. This is day 17 of Advent of Code. Yesterday's of Advent of Code, day 16, was the kind of puzzle that I particularly like because it had to do with parsing data and making a little mini computer which did hierarchical stuff, which was kind of neat, and it was a lot of fun for me. Although it was my longest stream yet. I mean, it was 2 hours just about from start to finish. So I don't know if today is going to be more of this. I think we're all set up to go. Let's just configure the repo so that we're ready for day 17. And make their source day 17. Oops, never exists because I typed it wrong. Mod.rs. Fun. Day 17. Day 17. Okay, so I think we're all set up, ready to go. That checks. We should hit test instead of run. Run. Yes, day 17. Okay, so we're set up and ready to go, and we'll find out what we have in store for. Oh, I did want to take a quick look at my stats first. If I look at my personal stats, I came so very close to breaking into 4 digits. I was off by 2. So close. I just wanted to point that out before we dive into day 17. Okay, here we go. I like this little path here. It looks like this is the path that we took through the cave system and whatnot, and now we're getting to the depths. All right. Let's read this. Day 17 trick shot. Oh, geez. I haven't transitioned over to my thing. Okay, so all I did was set up day 17, and then I took a look at this over here. Come on. There we go. To take a look at my... my rank was almost in the 4 digits. Like I said, off by 2, which is a shame. Okay. You finally decode the elves message. Hi, the message says. Oh, that was a message from yesterday? Okay. And all they were telling us was hi. We had to do all that work to get the word hi. Okay, nice. You continue searching for the sleigh keys. Ahead of you is what appears to be a large ocean trench. Could the keys have fallen into it? You'd better send a probe to investigate. Well, it can't be. We're only on day 17. But that's true. We only have a week left. So, the probe launcher on your submarine can fire the probe with any integer velocity in the X and Y directions. So X is forward and Y is upward or downward if negative. For example, an initial XY velocity like 0, 10 would fire the probe straight up with an initial velocity like, while an initial velocity like 10, -1 would fire the probe forward at a slight downward angle. The probe's XY position starts at 0, 0, then it will follow some trajectory by moving in steps. On each step, these changes occur in the following order. The probe's X position increases by its X velocity. The probe's Y position increases by its Y velocity. Due to drag, the probe's X velocity changes by 1 towards the value of 0. That is, it decreases by 1 if it's greater than 0, increases by 1 if it's less than 0, or does not change if it is already 0. All right. Oops. And due to gravity, the probe's Y velocity decreases by 1. For the probe to successfully make it into the trench, the probe must be on some trajectory that causes it to be within the target area after any step. Okay, so we're just calculating, yeah, like this little graph has. We're not looking to see if it's passing through. We don't have to calculate the line and see if it intersects the box, I guess. For the probe to successfully make it to the trench, it has to be within the target area after every step. The submarine computer has already calculated this target area, which is your puzzle input. For example, this. Oh, do we only get one? I'm just going to take a quick peek here. Oh, we only have 1 line. Okay, I can hard code that then. This is a lot of text. This target area means that you need to find initial XY velocity values such that You need to find an initial xy velocity value such that after any step, the probe's x position is at least 20 and at most 30, and the probe's y position is at least -10 and most -5. Given this target area, one initial velocity that causes the probe to be within the target area after any step is 7, 2. So we go over 7 up 2, over 6 up 1, over 5 up 0, over 4 down 1, over 3 down 2, over 2 down 1, over 1 down, over 2 down 4, over 1 down 5. And that's when we end up here. Okay, that makes sense. In this diagram, S is the probe's initial position. I guess S for sub. 0, 0, and the x coordinate increases to the right, y coordinate increases upward, right? Okay, I think we understand all of that. This is within the target area T. After each step, until the target area is reached, the position of the probe is marked with a hashtag. Okay, bottom right is both a position the probe reaches and a position in the target area. Right, I get that. Another initial velocity that causes the probe to be within the target area is 6.3. Boom. Right, okay, so it's down there. Another one is 9.0. It just hits the edge of that one. One initial velocity that doesn't cause a probe to be within the target area after any step is 17 minus 4. Right, because we hit 17, then we go 16, it skips over. Even though the probe must pass through the target area, it doesn't step into the target area, so it doesn't count. This makes sense. The probe appears to pass through the target area but is never within it after any step. Instead, it continues down and to the right. Only the first few steps are shown, obviously. Okay, if you're going to fire a highly scientific probe out of a super cool probe launcher, you might as well do it with style. How high can you make the probe go while still reaching the target area? In the above example, using an initial velocity of 6.9 is the best you can do, causing the probe to reach a maximum y position of 45. Any higher initial y velocity causes the probe to overshoot this target area entirely. Find the initial velocity that causes the probe to reach the highest y position and still eventually be within the target area after any step. What is the highest y position it reaches? All right. Well, okay, so this is interesting. I'm going to hard code these numbers in because why have a whole file and read the file in and all that kind of stuff? Oh my God. I am such a noob at this. Okay, here we go. So we're going to say min x is 288. Max x is 330. Min y equals -96. And max y equals -50. And let's make sure that these all stay the same type. Let's just make these all I64s. And that way we don't have to worry about overflow. We don't have to worry about negative or positive there. But let's see if we can reason out what the calculation needs to be here. Because this is obviously just like a physics simulation. We can step through each step. So if y starts out here y starts out as 2. So we're going to go 2 up, then 1 up, then 0 up, then 1 down, then 2 down, then 3 down, then 4 down. Right? So it's just, so one of the things you can see is that each one of these lines up with the previous position, right? So eventually, no matter what y velocity we hit, eventually we're going to hit a point that lines up with our y equals 0 position. So the maximum velocity that we can get coming out of y has to be the distance from something here that's something within the target, and I think it's got to be the bottom of the target. So that would be, okay, so if this is a maximum velocity of, this is initial y velocity of 2, eventually we're going to hit 3, which doesn't quite meet the target area, and then another 4. But if we have something here that's, let's see, this goes up 2 and then down 3. If we go up, we want to be able to go down 10, right? Because this is a -10. From before we saw that our min y was -10. we want to start with an initial up of 9, right? So we go up 9 and the 8, 7, 6, 5, 4, 3, 2, 1, 0, and then back 1, 2, 3, 4, 5, 6, 7, 8. 9 brings us to here, and then 10 brings us to here. So we can probably just calculate this directly, right? We know our min y is negative 96. So we have to shoot the probe up at 95 in order to make this 96 us to graze the bottom of that target area. So we can say println day 17 part 1 is, we'll just do a simple quick part 1 calculation, and all we need is min y to calculate it. Right, the lowest y position is going to be 1 less than the initial velocity. Min y is I64, and we're going to return, what are we returning? The highest y position. So we'll still do I64, that's fine. But the highest y position is just 95 plus 94 plus 93 plus 92 plus 91 all the way up to 0. And we've done that calculation before. Right? It's just the sum of 0 to 95, which is n times n plus 1 over 2. So in this case, it's just min y times min y plus 1 over 2. Okay, so did we just reason ourselves into solving part 1 very, very fast? How come that didn't run? Run. No, we're not using any of those. That's fine. We'll probably use them in part 2. Okay. Well, we got a number. And actually, we should be able to just verify that that's the correct number. It's minus 95 times minus 94 over 2. 4465. Oh. What did I do wrong then? Oops. I'm doing VI commands in here. It should be 4465. How did I get over 4560? Okay, now I'm very confused. Times this plus 1 divided by 2 min y min y. Oh, 96. Oh. Yeah, 96 plus 1 over 2. Okay, let's do the next step, which is this plus 1 over 2. 96 times 94. So, oh, 96. That's why. Okay. It's because I'm an idiot. 4560. All right. Stop being an idiot. Go up here, close those windows, delete those lines, run it again, and I'll fix the warnings on part 2, I bet. So I don't have to worry about that. Let me just grab this line here and put it up here for my login. Input data is this. Okay. 4560. Close this window. Go over here. Paste this in. Part 1 done. All right. So that was pretty simple. We're going to clippy it. There's not much to do. Yeah, I don't care about that. Git add source. Git commit -m day 17 part 1 contains warnings, but that's okay. We're going to use those for part 2, I'm sure. Otherwise, why have those? Okay, so what's part 2? Part 2. Maybe a fancy trick shot isn't the best idea, of course. After all, you only have one probe, so you'd better not miss. To get the best idea of what your options are for launching the probe, you need to find every initial velocity that causes the probe to eventually be within the target area after any step. In the above example, there are 112 different initial velocity values that meet these criteria. All these guys. Okay. How many distinct initial velocity values cause the probe to be within the target area after any step? Okay. So this is where we're going to write a quick test, because now I don't know. Mod tests. We're going to do a quick test here, and a function test. We're going to count velocities for, and we're just going to say assert EQ part 2. And what we have for min x, min y, max x, max y is, where is it? Here it is. So it's 20, 30, -10, and -5. And that's going to be equal to 112. Okay. And this should fail because part 2 does not exist. Oh yeah, I still have to do this too. Use superstar. And pub fun part 2. And I think for part 2, min x, max x, min y, and max y. And it's going to return, it's returning a count, so just a usize. So I think for this, we actually have to do the full simulation. So what do we need to simulate? For every possible y and x, and we know that our max velocity is going to be min y minus 1, right? We want to shoot it up at 95. Oh yeah, so this is 96. So that's going to be our highest value. It's going to be 1 minus min y. It's going to be our highest, because we're assuming that it's negative, and for our inputs, min y is negative, so that should work fine. And what do we want to start? I guess we can go from min y to 1 minus min y, right? I think that's a good range. And then what are good ranges for x? It's going to be, oh, this should be in. For x in, I don't know. We need at least to be able to get over there, but we have min y. Let's just start at 0, and just go to max x. I don't know if that's too much of a range, or if that'll work. So now we need to start simulating. So we have an x position of 0, y position of 0, and I need to make those mutable. And now to simulate it, we're going to just simulate in the time dimension. And what do we need to do for t in 0 to, I don't know, pick a good number. I'm sure there's a way we could just calculate it directly instead of having to guess, but let's just put in, I don't know, 1,000, and then we can play with it later. So now we're just simulating one t, right? So the y position, now we add, if our y velocity is y, we just subtract 1 for each t, right? So it's just y minus t. Y minus t. And then x is the same thing. We just subtract 1. X velocity decreases by 1 unless it's, and it's going to be greater than 0. So I'm not going to worry about this half of it. But once the velocity reaches 0, then we don't do it anymore. So we want to say if x minus t, right? X minus t is our x velocity at time t. If it's greater than 0, then we'll just say x pos plus equals x minus t. Right? I think that's correct. And then all we need to do is say, did we hit the target area? So if min y is less than or equal to y position, and y position is less than or equal to max y, and min x is less than or equal to x position, and x position is less than or equal to max x, then, oh, we need to count unique, we need to count, oh, every initial velocity that causes the probe to eventually be within the target area. So we don't have to find unique positions, we just need to find unique starting velocities. So all we're doing is counting them, right? Because each time we come through this T loop, it's got a unique pair, x, y. Let mod count equals 0. So count plus equals 1. Close all these for loops and return count. Is it this simple? Let's run a test. Oh, no, it's not that simple. I got 119 and we were expecting 112. Okay, so what did we do wrong? And this code makes sense. We start out at 0, 0. Our x position goes up by y minus t for each t. Our x position goes up by x minus t as long as x minus t is greater than 0. And then we just check to see min y is less than y pos is less than max y. Did I typo anything here? No. There are 112 different initial velocity values. And the only thing I can think is that maybe there's a pair that that would duplicate? That doesn't make sense. Just to see, just because. Let's create a hash set of all the velocities that are possible. Let mod hash set is a hash set from I64 equals hash set new. My brain is broken right now because I don't understand what about this doesn't work. HS insert XY. And then we're going to just say assert EQ count HS len. Run. Oh, I did run instead of test. Test. This is line 54. Oh, sorry, no, this is line 41. And it was the assert here that blew up. Println. It's just, I just want to see it. I don't believe the assert now. Yeah, 119 for the count. Oh, yeah. And 112 for the len. So there are duplicates. How can we have duplicates? How can we have duplicate XYs? Each one should be unique. What? Maybe it's really obvious to somebody looking at the code who's not me. But how do we have duplicates? All right, well, we're going to get the answer just by doing this. Return the len. Now the test should pass. Yes. And now we'll put it up here. But now I am really... So what are we passing in? Min x, max x, min y, and then max y. And change that to a 2. Run. It's slow. Almost 2 seconds. Maybe we don't have to go to 1,000. That's the right answer. Okay. But I don't know why it's the right answer. Oh, we did that pretty quickly. Oh, yeah, but everybody's going to do that quickly, right? If I look at my personal stats. Yeah. Oh, no, it's not as high as I thought it would be. All right. It still took me 10 minutes to get part 2. Writing all this, but I don't understand why this is what it is. Because there's 7 of them, so in the test input. So if HS contains XY, then I'm going to println XY is already in the hash set XY. And then I'm going to change this back to, I'm going to add 1 here just to make the test fail, and I'll run the test. Oh, I have to put an ampersand in there. Because I want to understand why this is doing what it is. How's it coming up? 11, -2 is already in the hash set. Println inserting this XY. Now it's going to be a lot of output. Yeah, so we have X is going 20, 21, 22. Oh, sorry. Wait a minute. X should be starting at 0. Oh, we're just inserting where we find entries. It's finding it twice in a row? Oh, I get it. Okay, now I get it. Let mute count equals 0. I get it. What we want to do is break. We don't want to keep simulating, because if one XY thing hits in the thing twice, okay. Now I get it. Thank goodness. And we're not using the hash. Okay, so that passes the test, and hopefully it still comes up with the same answer, which I forget what the answer is. 3344. It's still pretty slow. Oh, let me load up this again. 3344. Okay, thank goodness. Yeah, so once it hits the target area, we don't care about any other target areas. We only care about whether or not the velocity hit the target area. So we just want to break out of the time loop in order to look at future velocities. Okay. All right, that was pretty simple. Check in with Clippy. So all we did was add part 2 and add a test. Oh, and then I added that. I don't want an extra comment line there. Git add source, git commit, day 17, part 2. Okay, so that was really easy. That went very fast. That took me less than a half hour to do both parts, which in some sense is good because we got it done. In another sense is bad because we didn't have as much fun because it should have been longer. I don't know. All right, so the other thing I wanted to take a look at was, where is it? Here it is. This change here. So let's pull this out into a new window. There we go. So we can take a look at the code. So I want to do more, but here's the heap. And I did watch most of the stream. ModProg was going deeply into rewriting the A-star search code. You see, it's mostly the same here. The only difference is pulling out all this search and changing it to a simple lookup for in the binary heap for the lowest value, because we're trying to find the minimum value here for the F score. And if we put it in a binary heap, then all we need to do is pop to find the lowest F score. And then we also now have a loop that we can break out of to get the value, instead of just setting current and then keeping on the search and then having to destructure it here. We don't need to destructure it. Oh, yeah, the only thing I would do with this change set would be to remove these lines. There's no reason to keep this commented in here. But everything else looks good. And then this is the Dijkstra search. Oh, the Dijkstra search now does the binary heap. Okay, so why don't let me do this. Let me go back to this screen here. I can do, oh, that's too bright. There. What I can do is I did a commit. Let me push this up. Now what I'm going to do is I'm going to say cargo run. Which day was that? I forget now. It was just 2 days ago. Here it is, day 15. So if I say cargo run 15, release, because it takes forever. I'm just going to run day 15 in release mode here and see how long it takes to execute, and then we'll run the binary heap version that ModProg put together for us and compare. Oh, there we go. Part 1 comes out pretty quick. Part 2 usually takes about, what, 10 seconds? 8 seconds. And it came up with 29.95. Let's just double check that that's correct. Let's go to the calendar here. Go to day 15. Go to the bottom. 29.95. Good. All right, so let's merge this in. Let's go here. Merge pull request. Squash and merge. I always do squash and merge. Confirm squash and merge. Let's just, ooh, a reload page. It should just go, because we're not changing any file that got changed. There. Okay. It was just after the push I didn't need it to be done. Okay. So we're good. We're all merged, and now I should be able to pull it here. And then do another run. Oh, we got to clean that up, and we'll at the same time we'll delete those comments. Wow. Okay. Unfortunately, it comes up with the wrong answer. So that's a shame. Yeah, it should be 29.95. The only thing I think is maybe there's something that I didn't look at the code in detail, and maybe I should have looked at the code in detail. The Dijkstra search still has this. And I thought that changed for what changed here. Yeah, wasn't this in the Dijkstra search? Oh, this is in build part 2. Sorry, I saw this and I missed the blue bar here. All right. Well, okay, so we now don't have a working day 15. But it is much faster. Should we sit here and fix day 15? Let's change this to less than or equal, and get rid of the -1s. That was something I had, so it wasn't something that ModProg added. Let's get rid of these guys. We don't need those, and we're not using a hash set anymore, so there's no reason to have that. Okay. So the way the A star search works, let's just see. Right, so let's just compare. We don't need reconstruct path. So our open set start is the start location, which is we set that down here. And that gets added here. Okay, that's fine. Then we set came from to be an empty map. That's a text research. Where's came from? Oh, I guess that, let me split this up this way. Came from, here's came from. And it's just an empty hash map. Okay. All right, so now what we're going to do is for node n, g-score n is the cost of the cheapest pass from the start that's currently known. Map with the default value of infinity. So that's our g-score. Oh. Let's just make sure. Yes, so it's usize max. F-score is also usize max. Default value of infinity. And there's our heuristic, and we set the heuristic as the Manhattan distance here, width plus height. Okay. So that's done. So while open set is not empty, and that's what this is doing here, pop. And this is checking to see have we hit the width and the height. If we have, then we're going to loop over each neighbor, right? While open set is not empty, current is the node in open set having the lowest F-score value. Right? That's called found here. If we hit the goal, we do this. And then it says open set remove current. So where do we do that? Oh, okay, maybe that's what's missing. Maybe that's what we need to do, is say, oh no, it pops it here. So it does the remove by doing a pop. That's fine. For each neighbor of current, that's for D and DIRs, our tentative score is the score for the current one, plus the cost. Right. D is the weight of the edge from the current to the neighbor. Right. So that's that. That's correct. If the score, tentative score, is less than the score of the neighbor, and there's all this additional here. If A star score contains neighbor, or tentative is less than that. So that's a slight change to the A star here. Maybe that's an optimization. We'll have to take a look at that. A star came from insert. All right, so we're going to insert the neighbor. Right, that's a neighbor, and found is equal to current. Although we never use the came from because we're not doing the backtracking thing or the path reconstruction. All right, so now our g-score is equal to our tentative g-score, and our f-score is equal to the tentative plus the heuristic, which is the width minus the neighbor and the height minus the neighbor. And then we push that into the open set. If neighbor not in open set, oh, that's what this check is here for. Oh, maybe that's it. Maybe we're not coming and calculating because we're skipping over that step of it. Let's try that. So let's change this. Oops. Let's put it here and say if, and we're going to put it inside this thing here. So push tentative, blah, 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 blah. This goes over. I guess like that, maybe. Cargo will reformat it for us. So, okay, so now we're going to recalculate the G-score and the F-score, and then push the new one if it doesn't already exist. Right, so if neighbor is not in the open set. Oh. Let me undo all of that because I misread this. This is if gscore contains key neighbor. Then we'll do this. If gscore does not contain the key, then we don't go through here. That doesn't make, why is that? Oh, because we want to see. Okay, yeah, I'm gonna take this out. And take that out and just say if tentative is less than a star, then we're going to insert the neighbor into the came from. Right, that's this line. We're going to update gscore, we're going to update fscore, and then we're going to say if neighbor is not in a star, not a star, open set contains key. I don't know if this works with binary with the binary heap, and then that. I think that's the change that we need to do. And does this contain, it contains key, a star. It does not contain key. So Rust binary heap contains. Into vec, peak, mute, pop, reserve. Is there a way we can just find? And do we have to search the whole thing to see if it's in there? Shrink to fit. No, I don't see anything that says, does this contain a certain value? New with capacity, peak mutable, pop. Push into sorted vec, append, drain sorted, retain, iter, into iter sorted, peak, returns the greatest item, yeah. Reserve exact, reserve, shrink to fit, shrink to, oh, does pop take the largest item? Where's pop? Returns the greatest item, or none of it is empty. Right, and we want to actually find the smallest one in the open set, right? Where's our, oh, that was dumb. While open set is not empty, having the lowest F-score value. Oh, having the lowest F-score value. So we're adding in the highest F-score value. Right, because we're not doing the reverse thing. List binary. I can't check to see if the binary heap contains something, but we want to put in, where was the reverse thing I saw? Here. The min heap. Either core comp reverse or custom ORed implementation can be used to make binary heap a bin heap. This makes heap pop return the smallest instead of the greatest. Okay, so maybe that's what's going wrong. Is that we're ending up getting we have to wrap each value in reverse. Wait. This is inserting into the open set. Let me see something here. Where do we define the open set? Open set is a binary heap. Oh. So how are we doing the compare? How does it know which one's the largest and which one's the smallest? This is the F-score and this is the location that we care about. and we do a found on this, and we throw away the score. So what we can do, update my stream info. I mean my stream description here. So that's what we're doing. Now we're doing day 15 Redux. Okay. So what we're doing is we're trying to push in, we're trying to find the minimum. So what we can do is push standard, what are these values? I32s, I64s, U64s max, minus all of this. What are we pushing in there? Oh, usize max, okay. Right, and that way that'll flip the thing around. And of course this doesn't check because we don't have this. So what is this, 6 shift over and then delete this. Okay, so that checks. I'm gonna run this down here so I can hit release. And what we're looking for is off by 1. Ah, so close. So close. What are we failing on here? We're returning the G score here of the final one. Do we have test input anywhere? I thought I ran this with test. Oh, I do have test input. Right. It was fast, right? 1.8 seconds. So that's much better. 307, and it should be 315. Oh, is this the case where we're not adding? No, because 7 to 15 is adding 8, not 9. But that might be because we're adding this 1. Oh yeah, so we have to return the, I think we did this last time, where we added the cost of 0, 0, or subtracted the cost of 0, 0, and then added the cost of width height. And that's because I can't figure out where we're adding it in and where we're not adding it in. The initial cost G-score is 0 for 0, 0. So I don't know how we get that extra 1 in there, but let's see. So we're going to break here, and we're going to subtract minus the A star cost get 0, 0 unwrap plus A star cost get width A star height minus 1 unwrap. It's a little sloppy. It does come up with 315, and now with our real input, $29.95. Okay, so I think that's better. It's certainly much faster with the binary heap instead of searching linearly through the thing. It would be nice to understand why I need to do these 2 lines here. I don't understand why I need to do those. Why it's just not calculated as part of the thing. God, whoa. Hi, thank you for joining the stream. Oh, and I missed a follow 26 minutes ago from Fish and Face. Thank you for the follow, Fish and Face. I don't see it pop up on my screen here, although I expect you see it there. I'm just not paying attention. All right, so I think this gets us, this gets us a fairly decent time for day 15. So let's get this checked in. Let's see what Clippy has to say about it. Clippy likes it. Get add source. Let me do this. Let me do cargo run all. Run. -8 runs all of them. Yeah, day 12 is still pretty slow. And day 15, yeah, it takes 2 seconds. That's okay. All right, I think we're good. Git add source, git commit -m, day 15, fix up. And we'll push that. Okay, that's good. Thank you, by the way, ModProg, for your help there with speeding that up. Godwell asks, what heuristics did you use? I went with the simplest possible one, just the Manhattan distance. Here, I just did the Manhattan distance. Actually, we can clean this up a little bit more. Just say let f score equals this, and this, and then just say f score, and then say umax minus f score. Something's not lining up right. I simply use risk levels for everything. Oh yeah. Maybe that would have done the trick. The thing that ModProg told me, because this is the first time I implemented A star, was for this problem. ModProg said to make sure you're not overestimating on the heuristic. Make sure you underestimate on the heuristic. All right, what I'm looking up here is this. Oh, this has to be usize followed by neighbor. Okay, so, and it's a tuple with a tuple inside it. I see it. So I think we can just do this, comma, neighbor. I think that's the whole thing, because neighbor is already the tuple we need. Let's see if this checks. No, it does not. And I missed something. That matches that, that matches that, and then we have an extra one. Okay. Oh no, I mean we need an extra one there. Yes. So this is not necessary. Okay, that's what messed me up. Unexpected token, because I missed a semicolon. F score. All right, and now let's see. $15. There. Godwell says, never done any pathfinding or graph algorithms before AOC, so it was fun to learn on the fly. Yeah, so I had implemented Dijkstra before a few times, just for classes, right? You know, you go to class and say, okay, implement Dijkstra to do this, blah, blah, blah. And so I had done that before, so that was kind of familiar to me. Where's my Dijkstra? Here's my Dijkstra search. I still referenced Wikipedia to make sure I wasn't forgetting anything. So there's the Dijkstra search, and then there's the A star. So yeah, I agree. It was fun to learn doing that and understanding the difference, because I knew A star was better for some reason, but I didn't know why, and now I get it, right? Okay, so let's push this. Make sure everybody's happy here. Git add source, git commit -m, more day 17. Futzing. Yak shaving is great. Okay, so the last thing I wanted to do, since we have so much time, was to take a look at how long is your A star input taking for part 2 scaled input. Well, I print out the completion time here. Is that the number you were asking about? It's just under 2 seconds for both. It's for both parts, but the first part is very, very fast. So hopefully that's the number you were looking for. It was over 8 seconds long before ModProg added the binary heap to keep all the F scores sorted. So my main has a bug in that if it is not December and you don't give it any arguments, nothing happens. Godwell says, I did mine in Go with test lowest risk input scaled, and it took 0.32 seconds. That's okay. That's cool. I must not be doing the rest of my code right. Or I just implemented the naive solution for this, right? I just followed the steps step by step, but there's probably some optimizations you could make. We also don't need this, for example, the came from. We don't use that because we don't actually need to find out what the path is. We just need to know what the cost of the path is. You implemented it very wiki-like too? Yeah. Okay. So there must be some more optimizations we can make here. But for now, I just want to fix up my main so that if it's not December, we just run all the days if there's no arguments. So I think what I want to do is, instead of doing it this way, I just want to set let run all equals false, run day equals, and I want to get the current day. How did I get the current day? Oh, using this. So I can do this, let today is now. I can say run day is going to be today, today day as usize -1. Which we'll call it which day. And then say let not run day is false. And then if args is a, then we just want to say run all equals true. Otherwise, if it is not, then if it's day, then we want to say run which day is this. And then if it is not greater than 1, in other words, it's 0, we want to run if it's month of 12, then we say run day is this, like this, else run all equals true. And then we say if run all for d in days, d, oh, run d, else, oh, we don't need run day. We just need to know which day we want to run. Else, run days of which day. There. Now if it's not December, it should run all of them. And what did I break? Run day. Oh, which day? And this is just day -1. Okay. So now if I say cargo run, oh, it has to recompile, but it should just run day 17. That's pretty slow, but okay. Maybe I don't have to go to 1,000 on day 17. And if I say cargo run 15, we should get day 15. And then when it's not December, I can test the last code path. Dover, thank you for the raid. We just finished, and we finished day 17 pretty quickly because it was just math. We went back and looked at day 15. ModProg had actually submitted a pull request for day 15, and we looked at that. We merged that in, and then we tweaked it some more. Day 15 in release in debug mode takes 35 seconds, and that's with the binary heap. And in release mode takes less than 2 seconds. Yes, okay, and then we should be able to do -A to run all of them. Indeed we do. Okay. So let's check in with Clippy, make sure, oh, no, we can change something. Oh, okay, we can clean that up. Sure, let's do that. We can just do this, shift that in, and get rid of the extra guy. All right. And then, good. Fix bugs in main. Godwo says, got a little request. Yeah, go for it. Meanwhile, what was the other thing I wanted to take a look at? Let's see. How am I doing here? Oh, I'm in 4th. Nice. And toggle bit, I am in 6th. Good. I'm climbing up the ranks. Let's see, did Alan do it? No, he did. He stopped. That's a shame. That's a shame. And then Chael. Godwell asks, can you change the heuristic to simply risk level instead of Manhattan distance? Yeah, let's do that. That should be easy enough to do. So instead of doing it here with the calculating Manhattan distance, we'll just add the risk level. A star cost get found unwrap. Wait, we're already adding it here. Huh, wait a second. We're already adding it here. Why are we adding it again? Is that something that, oh. Tentative score is the G-score, right? We get the G-score. Plus, oh, that's the D. And then we can just add it again here. Okay, okay. Okay. I think we're good with that. So we added it to tentative and then we add it again to the F-score. That's fine. So we're using D, our distance, and H, our heuristic, being the same values. Let's see if that should check. I'm going to run this in release mode. It's about the same. It's about the same. I mean, maybe a little bit faster. Where's day 50? Yeah, this is 1.9 for this particular run and 1.8. Although, you know, part of the problem is I'm running Pretzel Rocks in the background and OBS in the background, and I got other things running. So there could be some interference there. Maybe if you run it on a non-busy machine. I don't know if this obviously estimates a larger value here, right? Because cost can only go from 1 to 9, whereas this will be the width. This could be up to the width and height of the Manhattan distance to the final location. So I don't know if this would underestimate by too much and end up taking longer, or if the underestimation is a good way to go. Yeah. And then we just do max minus F score to flip the thing around. Okay. I guess you'll never know. Well, I mean, you can always, I mean, here's my repo if you want to play around with it. Let me grab the link. I'll put it here. Feel free to play, and if you have a PR, I will take a look at a PR like I did with ModProgs. Right, we did that. We pulled that in today. So, yeah, definitely, Godwell. Let me know what you discover. I will check. We'll undo this though, so that I'm up to date with my repo. And I think that's it for Advent of Code for today. Let me switch over. So the other thing I do on my channel, for those who are here for Advent of Code, is I've been working on a roguelike using this roguelike tutorial. And I have another hour or so, maybe a half hour to an hour, to look at. Let me close this. I don't need that one anymore. And that's something I'm going to look at next. So here's the roguelike. We're building a roguelike, and the last time we worked on this, we ended up breaking how we spawn goodies. So let me see if I can figure out what the bug is for that. We were on the free prefab session. Is $29.95 the correct answer for your input? Yes. For day 15 part 2. Yes, it is. $29.95. You got 400 milliseconds. Okay, maybe you just have a super fast machine. Is that with your code, you're saying that you have you got 400 milliseconds with your code. Yes. Okay, I got it. Okay. Yeah, I definitely like to see what the difference is then between our implementations, because I'd love to be able to get this in under a second. That would be awesome. Okay, so let me change my screen title a second time. Rogue like tutorial. Prefabs. And we'll do that. Let me do a stream marker while I'm here. I'm adding it at 108.28.